Fine. Thanks for joining. Today is actually recording number 5 and it will be day number 7. Okay, Steven, yeah. 8 and maybe probably I'll cover 9 as well. So day and 8 and 9 I'll cover today. Recording number 5. What we have done so far, you can check that blog. I have uploaded all those documents, important information in this particular blog. In this blog, you don't have only this thing, but in case if you are looking for Python training, so let me quickly give you preview about this blog. So if you go to this blog, in this blog, so far I have updated 3 topics. One is related to my CCI training. So for that, you have all the YouTube link. Whatever YouTube link I have for my CCI training, that is there in one blog. Then one blog I created for the Python training. But this particular blog that I have for Python training, I'll put you guys on mute. If you want to ask anything, you can unmute and ask. Okay, for this Python training, how it is. So let me show you this. For Python training, day 1, 2, 3, 4, 5. Uh, some questions are there, right? You can go and answer your questions, whatever mutable, system mutable, and it will give you the answers here. And then not only that, but in case that if you do not have Python installed in your laptop or your system from where you're checking all these codes and all. So what you can do here, I have added the Python. You can see the Python in the browser. So if you have any type of code, right? For example, if you have this code, you can click copy and you can delete whatever the existing code is there, and then you can go and run this. You need to call the function, otherwise nothing will print. If you run, see, any type of program you can go and run here. A small type of integration with Python is there in this blog. You can run your codes. So day 1, at the moment you'll go and complete day 1, bottom you can see the YouTube video as well. So read those documents and watch the video. And then like you have day 2, day 3, and the same page, I have added all those days. 1, 2, 3, 4, 5. Basic, somewhere you can see that it is overlapping the page. So you can increase the font, control minus, check these documents, scroll down. These are the scripts you can go and test. Scroll down. And if you need, you can increase the font size. Like that, you can study. This time we are going to look our SD-WAN. So if you come to the bottom, I have added that bookmarks or the links here in the bottom. So if you come to the bottom, you can see that Python training, SD-WAN training, full document is there. And then you can see the CCI training. If I go to CCI training, I don't have the document related to CCI, but all my YouTube videos links are there. Oh, sorry for that. Oops, what happened to this? My internet is gone. Wow. Strange. Anyways, that link is there. I don't know why it is not opening. The link is there. CCI training link is there. If you're unable to find, then I will give you a separate link for that, but is there. Anyways, come back to our training. So what we have done and what we are going to do here is that we are going to look into the concepts of OMP, and if time permits, then we'll go and do one hands-on lab related to the OMP and TLOC. Before I move further, I'll ask you guys that tell me that what's the use of OMP? What's the benefit of OMP? If you have any thoughts on that, you can say that.
So, so OMP is like your obviously you can compare it to, as you say, a BGP to the edge device between your vSmart and the edge device. therefore giving you that security and a tunnel like for your 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 VPN zero, etc., to connect across. Um,
Yep, that's right.
and yeah,
Yeah, that's right. So you can see that OMP is overlay management protocol that distribute the next hop. TLOC is nothing but next hop BGP type of attribute among the different sites of SD-WAN. Then it will provide the distribution of the services like firewall or any security appliances that we have in the fabric to all the locations. It can do service chaining, like redirecting the traffic towards different devices. It will go and help to establish the data plane tunnels like VPN levels, crypto keys, etc. And it will go and help in the policies as well, like control policy and data policy. So that's the overall use of OMP. It's the orchestration type of protocol you can think, but it's a overlay protocol. So whatever physical connectivity we have, whatever underlay we have, on top of that, this overlay is working. That's the whole concept about overlay management protocol, right? Okay. Now, if we try to understand OMP, you can understand with this particular diagram. So let me try to give you the explanation of this particular diagram. Here you can see that we have two different sites, site 1 and site 2. And in this site, suppose if you want to advertise some prefixes from one location to other location, how you can go and do that? So for example, suppose this is one of the site. Here I have one prefixes. Suppose prefix 1, site 1 prefix. This is A, right? In this particular site, this is connected with three different ISP. You can see that internet, MPLS, and 4G. Okay. Now, this is where this particular prefix is where this is connected to service side VPN. Service side VPN. And we know this thing that if any service side VPN, it has to go, right? It has to go and reach to other side. First of all, internally within the router. Suppose this is a router. This circle here is a router. So within the router itself, service side VPN should map with VPN 0 because your entry and exit is via VPN 0. So irrespective of n number of VPNs that we have, VPN 1 up to VPN, for example, 511, these should be mapped first of all internally with VPN 0 because VPN 0 will provide the gateway to go outside inside. So it will go and internally trace with VPN 0. Now VPN 0 from one location to other location with VPN 0, right? So this VPN 0 here that we have and this VPN 0 that here we have, some data plane tunnel is there because actual data where it will move, the actual data will go via the IPsec tunnel, right? But the control information, right? The control plane information that will go to VSmart. So I have VSmart where the edge device and the VSmart devices, right? They have the connection. What type of connection they have? We know that from the edge device to the VSmart, we have some sort of DTLS connection, control connection, DTLS or TLS, transport layer security, right? Now this big pipe that you have from your V edge to VSmart, one big pipe is there. That is the secure channel, control channel, DTLS. In this big pipe, you may have the one protocol running within that. That is your, let me try to draw here, the circle. One pipe you have for OMP, right? Overlay Management Protocol. Correct. Now we know that, okay, some VPN 1 have some prefix, for example, prefix A, that will reach to VPN 0. And now this VPN 0 has the overlay management protocol communication, or overlay management protocol. You can see the a better word is peer. So it is peering with vSmart. So your edge devices are peering with the control plane, which has all the control related to routing change and exchange, with help of protocol, that is OMP, right? But you have three different ISP. So how your vSmart will come to know that the A network that I am getting, it is coming via internet, or it is coming via MPLS, or it is coming via 4G. So for that, whenever this prefix A will get advertised via OMP updates to the vSmart, not only it will learn A, but it will learn that via which path or via which TLOC to the specific, I am learning it. So that is the one-way communication which is happening here. So A is coming here. Now once A is coming here, then it is seeing that, oh, who is my VSmart, who is my OMP peer? Oh, VSmart. Okay. So to I have to send that. So now this device will think, oh, how many TLOCs I have? I have TLOC 1, 2, 3. Okay. Now I want to see this to the VSmart. I need to send this to the VSmart. So when it will send that A, it will send with TLOC 1, TLOC 2, TLOC 3, right? Internet MPLS 4G. Now VSmart within its own database, OMP database, it will go and register prefix A with three different TLOC, TLOC 1, 2, 3. Now, since it is working as a route reflector, it also has to send the update. You can see the route advertisement to the connected devices. So now it will go and send that update to the connected devices to over VPN 0. It will send to VPN 0, right? VPN 0 will go and learn A via OMP update, but in that update, it knows that it has three ways that I can reach there. So it will go and register here, and it will go and handle. If it is part of VPN 1, so it will go and send that prefix to VPN 1 only. That's all these things are automated. We do not have to do anything. Automation is there. You know, this SD-WAN, we have some automation. What automation we have? First of all, the OMP. It is automated. This OMP protocol automatically they are sending, receiving the updates, etc. That automation is there. The better automation we have related to IPsec. You know, for DM VPN configuration and all, how many phases of configuration we have to do to the hub and spoke everywhere. Here, you're not writing a single code. At the moment, the control plane and data plane will come up. Automatically, it will go and install that, that IPsec tunnel in between the devices. Okay, so that is very much the flow. With help of OMP, they are learning and advertising their network to each other. That's the OMP. But OMP is huge. You can see that list. Actually, everything in the network, whatever network communication we have within the network in SD-WAN is done via OMP. Everything OMP is doing, because vSmart should know it's a firewall route or TLOC route or OMP, whatever, it should know. So if it will know, then only it can control. That's the whole idea about here. I will go and show you these connections, these configurations and all. Here you can see that the vSmart can be OMP peer with vSmart, and vSmart will be the OMP peer with the edge devices. But edge devices with the edge other edge devices, they are not OMP peers. Different type of messages types we have is OMP types we have. So I have categorized that OMP having OMP routes, OMP TLOC routes, services routes. I must have one topology here. With that, I can explain you that. So let me check my topology of the OM. Quickly go to, I think it is in the T1.
Ratnesh, in this one, there is a point like it identifies the firewall routes as well. So how it identifies the firewall route?
I'll explain it that. That's why I'm looking for my topology. Once again, let me see where is my lab topology. Is in day number, I think in day number 1. I'll answer you that question. Yeah, here it is. Okay. So this is actually the lab topology that I'm sharing with you. This is our lab. Now, if you see this particular lab, okay, let's increase the size here. Okay, okay, right. Let's try to understand this lab. In this particular lab, we have data center. This is the hub location. Suppose this is DC1 and then this is DC2. DC1 and DC2. In our lab, we have only DC1, but DC1 and DC2. And then we have branch 1 and branch 2. Like within data center, you see that we have one firewall here. Okay. And here you can see one firewall. All right, great. So I told you that OMP can recognize 3 different routes. What are those routes? First of all, OMP routes, or it is
The
named as, yeah, it is named as service side VPN routes. That number 1. So this is number 1. Then OMP can go and identify OMP TLOCS. That's the next gateways. And then OMP can go and understand services. Services are security services routes. I'll, I'll explain all these things. 3 routes they can identify. Okay. Now in this diagram, if I go and highlight. So for example, I'll go and use green color for type 1 route, that is OMP router, service side VPN. So where is my service side VPN? All these routes that you can see here, we have say VPN 10, 20, and 30. All these routes except the firewall. So I should exclude the firewall. Let me try to draw one more time. All these routes that you are seeing here, here, and then if you're here, these are your service side VPN routes. They are part of service side VPN, right? So this is nothing but type 1, type 1, type 1. Now, next we have, let me go and use some black color for TLOC. So where is your TLOC? Your next hop, where you're connecting with ISP. Your next hop, where you're connecting with ISP. So this black color is your TLOC, for example. This is 2, 2. This is 2, 2, 2, type 2. Then I highlighted services route means the location of firewall, VPN, SSL, etc., etc. So those I will go and highlight with red color, for example. So this firewall that you are seeing here, this firewall route that you are seeing here, this is 3. Location of your firewall, right? Now all these 3 routes, 1, 2, 3, your VS Smart will get these information via what? Via OMP update. Via OMP update, it will receive these routes. Okay. So that's the reason the VS Smart will know that where is the firewall. And when we'll do the service chaining, so I can redirect the branch traffic towards the firewall, and from firewall it will go out, and then it will come to the firewall, and then it will come here to the branch. So this is redirection of traffic or traffic engineering we can do. Why? Because my VSmart knows. So tomorrow I'll go and create policy. in a way that with policy, with some control policy or data policy, we can redirect the traffic towards the firewall in any location, and then traffic can go out and come in. Like that we can do. Any question?
No.
But good question, yeah. So let's go back here to that day number where we are. Day number, I think 8. Let me go back to my dashboard. If from here also I can go, no problem. And here we are. So OMP explanation is actually easy to understand. The 3 different routes are there. Whenever the TLOC is coming into picture, just understand that TLOC is nothing but, I have mentioned here, should be mentioned here that it is BGP next hop attribute. It's not mentioned, but mind it. It's a BGP next hop attribute. Service routes, what? Firewall, IDS, IPS, whatever there, that is your service routes. That is one part, right? Then OMP route installation, how it will go, and so all the flow that I told you. So here I have added the flow as well. The same way, I'll explain one more time. So they have some prefixes. They will go and send to VSmart. VSmart is working as a route reflector. It will go and reflect the route to the other locations. This lab I'm going to show you in maybe next 5 minutes, so don't worry. Then what are the TLOC attributes and what are the OMP attributes? These are important attributes we have. In BGP also, you know that BGP having how many? 13, right? 13 different attributes. And with that, with that attributes, they are the features you can think like that. With that, they can go and provide you best path selection. Means what will be the best path, that with those attributes, we can get that or we can reach to the best path or best destination, but it will provide you the path. The router whole idea of the router was to provide you the best path or the path, to show you the path, right? Here you will see that within TLOC, public IP, private IP, color, encapsulation. At the moment, we know 3 things: color, encapsulation, and system IP, right? Where is that? It's public and private IP. System IP, color, encapsulation. Anyways, from the document, it's not showing you system IP, but TLOC having 3 major attributes: system IP, color, encapsulation, and these are the additional attributes we have. Yes, TLOC having these information. Okay, these are the TLOC route attributes. Then what are the OMP attributes? OMP attributes: origin, TLOC, color, encap, preference, site ID, tag, community, and VPN labels. Maybe in case of MPLS, you need these labels. Um, by default, they are putting these tag values and all in
And
the
is it a root preference and TLOC preference? Both are different.
this
Like
TLOC
here,
preference and this OMP preference. Both are 100% different. Whatever
because
attributes we have,
Mhm.
suppose if you see wait here and wait here, although it is not there, but both are different. OMP is different, means whatever attributes you can see here, like for example, preference is different. So OMP preference is different and TLOC preference is different. Okay.
Okay, so every we have 3 service provider, right? And 3 service provider will create 3 different TLOC. And out of these 3 TLOC, we will give preference to any particular service provider. That will be done using TLOC.
TLOC. Yes.
And in OMP, how it will be done, like root preference, I think I'm confused, like how it will be.
So you have your question, I'll answer. I got your question, I'll answer in 2 minutes. Yeah, I'll answer. Don't worry, I should get that. see where is the answer, then I'll answer that. Don't worry. So here let me go up. It is not here in this document. Just a second. Your question is valid. I'll answer that because I have that answer with me. Just, I need to
Okay.
open one document. Allow me 1 second. Let me go and open that
Okay.
document. Where you are, SD-WAN use cases. SD-WAN. Where is my document related to OMP? Second. Mm, mm. So let me see that where I have my OMP topic. This is document 2. Okay, let me open document 3. Cisco OMP. Okay, so check this OMP best path selection, and then you will get your answer. So when we have to go and select the best path, first path is check the validity, next stop is valid or not, otherwise leave it. If OMP route is valid and if had been learned from the same Riptela device, then check the OMP route with the lower AD value. You know that how the routing decision done. Lower is better most of the cases. Lower AD value wins the race. It will be selected and put in the OMP table. If the administrative distance are equal, select the OMP route with the higher OMP route preference. See, OMP route preference. You can see this is coming under point number 3, OMP route preference. But if I go to the next slide, now you see here. On VH routers only, if OMP route preference values are equal, select the OMP route with higher TLOC preference. You got my value, a point here. So first criteria is OMP route preference, and after that we have criteria for TLOC. So, but if the OMP route preference we do not set, for example, that means default, that means equal, then we can go and select that with the TLOC preference. Okay, so this is the best path selection criteria we have in the OMP.
So OMP will supersede the
TLOC
TLOC
preference.
preference.
Yes. All right, and videos are there. Few videos, good videos are there just for your reference. That is there in linked in the blog as well. So OMP best path selection. Just now we discussed that it will go and check the validity of route, then the AD value, then the OMP preference, then the TLOC preference. Like that, it will go and check the parameters. It's not like BGP best path selection criteria where you have so many things. Only 6, 7 points are there. On the basis of that, it will go and select the best path. Okay, so now what I'm going to do here, I'm going to show you one lab. Okay, in that particular lab, I will go and create one network 99.9.9.0/30. Okay, and with that particular network, I will go and add this network in one of the router. So if I go and show you the diagram is there in the bottom, and all these lab steps I'll follow. This is the lab diagram. I will go here and create one network on the branch to edge device, some 99.9.9, and then I will show you that this network is reaching where to the VSmart, and then VSmart is working as a route reflector. It will go and reflect that route to the edge devices in the data center. Okay, so the flow I will show you, and then we will go and verify OMP peer, OMP routes, OMP advertised routes, OMP learn routes. So here is the configuration you can see that I want to do. I will go to router, I will create the IP address like this. I'll commit it, because since this template, let me try to open this, is not attached. If you attach it, if you attach this device, you have to go and do these things via the template. Now what I'll do, I'll go and detach. Okay, and then I will create the loopback with the configuration just to show you. Not in the standard way. This is not the standard way we are dealing with Cisco SD-WAN, right? We are doing everything via the template, some configuration, some template, some feature template, device template, right? But in this case, just to show you some difference, while you do some troubleshooting and all, you can go and detach the template from the VSmart. Once you can go and detach the template from the VSmart, after that, you can go and do the CLI configuration, save it, then you can go and save it, no problem. And then you can do the troubleshooting. Once you do the troubleshooting, once you find that what is the configuration item missing, then you can go and re-update the template within the device, and everything will be managed via the vManage. So like that. So let me go and log into this device first. Just first time login, it will take some time in this lab. Let me try to put username and the password. Admin and the password. I need to onboard that device. That device is actually not added in the dashboard, the branch to edge one. Go to the menu, configuration, template, device template. And this is not attached with anything. So I'll go and attach one device whose initial configuration is there, cloud configuration is there. Simply I need to go and click next, next, next.
So new device onboarding and offboarding, can we do in DCloud as well?
DCloud, why not you will do that? I have created one video for that. So what I have done, I'll give you the link
This
for that.
this 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 lab, is it in your home network or in DCloud?
Yeah, so let me complete. So see, this DCloud controllers that you have, right? The controllers that we have, it can be anywhere. Your controllers can be anywhere, and your edge devices may be in your GNS3 or anywhere. So what I have done, I have connected my GNS3 with the DCloud. Okay. And then I have installed some local routers in GNS, and then I connected to DCloud. So that lab is there in my YouTube video. I can give you that link. You can check that how to do that.
Yes. Yeah, yeah.
You can't be reached. Okay. Meanwhile, it is working in the back. You don't have internet connectivity. Great. I'll ping you that in the WhatsApp chat, that video. But if you search CCI with Ratnesh GNS3, you will get that video. Let me see here. It should work here also, like CCI with Ratnesh GNS3.
Actually, in YouTube, some of the videos are
vManage.
restricted, so I'm not sure whether we will be able to access or not.
Some of the premium content you can say.
Yeah. So for us, it should be right.
Yeah, I open so many videos on request. I have CCI batch, so all my CCI training videos are free now. Even DNA was some training videos. I have.
We are a regular batch joiners, so those
Yes,
premium videos for us also.
there is no option like I can give some access to some students. That's not there. Otherwise, I could give you that access. See, this is GNS 3D Cloud Connection, see, SD-WAN Home Lab. So let me quickly show you this. If I can go here, it's like actually a little bit slow, but idea here is that the same thing that you're asking, you can follow this step because you need to generate some sort of serial number and chassis ID. How to do that forcefully, I have shown there. And in my GNS3, so this is there. You can see 198.181.10, right?
Mhm. So in laptop, what is the configuration it is required? Like if I want to run vManage and vSmart, vBond, everything, and at
In
least two
laptop,
CH.
you need 128 gig RAM laptop. It's not
Okay.
possible in laptop.
Hmm.
See here this diagram. So CSR, yeah, dcloud. This I install in this, and then in the cloud somewhere you have that dcloud, and this will get connected. It will get registered and it will show there in that we manage this local device. Then I have shown this inbound, outbound connections and all those things. Nice video. You can do research. That time I was doing some research, so I created that. You can see VS Smart D Cloud, VS Smart D Cloud. Then you can see VH Cloud that is in my laptop, GNS3 VM. Some debugging, some issue, but it was there. It got registered. Okay, so I can let me ping you this thing. Maybe hard to find later on. All right, let me close. Okay, so it is there. Now what I will do that I will go one more time to the configuration and templates. Let me detach that template from here. So I'm here, detach, because I want to run this via CLI. Detaching is in progress. It will get detached. Let me go back to my lab, interactive lab. Okay, so I have this we manage. Let me try to connect 198.181.10. Yes, get connected or not today. I need to start the server to get this connection. One sec. CCI, where are you? Let me start my proxy services so it will get connected. Close this and try one more time. So anyway, no problem. I have other access as well. I will check, fix this later on after the class. But I know that how I can go and access this. Due to some VPN issue, it's not working at the moment in my laptop. I'm violating some rules here. Anyways, I have that GNS3. Let me go there. Let me restart this reconnect. Okay, so from here you can check show control connections. I just wanted to see that where is my edge device. I know that IP is 10401, and for this particular edge device, I can go to vshell, the Linux shell that you have, and from there I can go and SSH to my system IP 10.4.0.1. That's the edge device. Wow. Warning. Some warning. It is strange. But it's not connecting here. But anyways, no problem. I have that as a branch to VH1. You can see here in this bookmarked here. So anyways, I'll get connected because of out of band management IPs and all. That's fine. But from vmanage also you can do reverse telnet. So moment it has some issue, no problem. So we are here, right? Now, if I go and check show interface description, I can see list of the interfaces, VPN0 interfaces within that. I'll go to VPN 10, okay? And inside that, I'll go and create interface loopback, say loop back 99, and then the IP address 99.9.9.9 slash maybe 32, and then no shutdown, and then commit and quit. Commit and quit. So commit and quit. And then if you go check show interface description, you'll see that within VPN 10, I have loopback 99, which is up and running, right? Now what I will do, I'll go and open a vSmart 1, for example. So here we are within the vSmart 1. And maybe admin username and password. Now if I go and check show OMP, first of all peers. So vSmart is peering with vSmart, and it is peering with data center devices, 2 branch devices and 1 branch 2 device. So it has these many peers. Then how many routes it is sending and receiving, receive and send and installed. So those informations are there. Straightforward. Now we can go and check show OMP routes, right? In this list, you will see that under VPN 10, it is receiving route from both the vSmarts. So actually we have two vSmart, vSmart 1. So it is receiving from this and it is receiving from other vSmart. So two places, my vSmart 1 receiving 99 route via this and via this, right? And you can see clearly the TLOC information. System IP, color encapsulation. System IP, color encapsulation. Correct. So this is the story about vSmart. But vSmart is working like what? It is working like a route reflector. So if I go to any of the data center device, suppose DC1, VH1, and if I go and search that particular route, but within that VRF, remember this thing is very important because it has labels. If you see the route again, it has a label of VRF. Okay, come on. I think that is not get connected. Let me reconnect.
So at peer side, it will be communicating only with the VRF 10. If
10 within 10, yeah. Within the router, outside the router, but within the same fabric, yes. So you can see the label here, 99, and this route within the OMP. So if I go and check here, show OMP, OMP routes for VPN or VRF 10. I can specify 90.9999.9/32. It will give you the information with all the attributes, right? So yes, it is receiving this from where? From VSmart. This is VSmart system IP. Path ID label CIR. This is CIR means this is the legend. It is telling that it is confirmed installed route like that. So let me show you this legend's full form. Something like, yeah, installed, chosen, and R for resolve. Resolve, install, and chosen route. Like that. You have the CIR. Then you can see the attributes. Who is the originator? What's the TLOC? What's the site ID? If you set the preference, if you set the tag, if you set the origin, like, all those things. So it is not only it is receiving the route where we are at the moment. We are at the other end, like other site. This is just DC1, VS1. But when VSmart is sending this route information, it is sending with all those attributes. Why this is important? Because in future we can go and change it via VSmart. So we can go and put some OMP tag, we can go and put some OMP preference, we can go and put some TLOC weight or TLOC preferences. Like that we can manipulate it. So manipulation is there, highly tunable. See, at this point of time, the Cisco SD-WAN VipTel or Cisco SD-WAN has the best routing capabilities, enterprise level capabilities with respect to any other vendor. So it is enterprise level routing mature and it is enterprise level security mature SD-WAN solution. So this was the lab related to this. Anyone having any question, doubt?
So since it is getting from both the VSmart, so is there any way it will identify that, okay, we have to trust only, or we have to take the routes which are coming from VSmart 1 or 2?
Yes,
How
your
it?
question is really good. Awesome. Yeah, so I'll show that. If you go and check, so OMP, let me clear this first of all. Show OMP PS. And let me open the VSmart 2 as well. PS. Let's see. So let's focus on the this place here. Okay, let's see. Let me try to draw the diagram. Both are on PPL. This is VS1 and this is VS2. Okay, now let's see. Sending route, how many? 14. So VS Smart receiving 14 and sending 68. What does it mean? That VS Smart is sending 68 routes to this device and receiving 14. This is your, for example, VH1 is sending 14 and receiving 68. Okay. Now At this point of time, if you see both the VS Smarts, both are the same, sending and receiving, no problem. That means VS Smart database, they have some common database. That means obviously it should have common database. Both the VS Smart should have same number of routes within their databases. So it has some common database. Now let's go and check the DC1. When DC1 is receiving, show OMP routes VPN 10 in tab formats, in tabular format, table format. I just wanted to see this result that we have 99. We are focusing on 99. So let me just scroll up a little bit more. Okay, here. Now check this. When the other, so let me go and complete the diagram. Let me go and add, suppose this is the DC device data center DC1 VH1. So now it has this 99 and now it will send, both the VS Smart will send, right? VS1 and VS2 to DC1. So DC1 should take the VS1 and install, or it will go and take VS2 and install. That was your question. This or this, and how it will be. Let's see. In this case, the 1212 is VS Smart 1 where you can see CIR. CIR. So by default, what in this case, what this system is doing, that is it's checking VS Smart 1 as a primary, like, EIGRP primary and backup path, and VS Smart 2 as a backup. So from VS Smart 1, it is trusting more and installing the route, right? And VS Smart 2, it is putting as a backup. The 22 is a backup because you can see only C and R. Is it resolved and it is chosen, but it is not installed. Now, if anything will happen with VS1, then you will see the CIR to VS2. So if I can go here and reboot this, reboot. So now your VS Smart 1 is down. Now if you go here and check, still it is in progress seems. Still it is receiving routes from VS Smart 1. System is going to reboot now. It's not rebooted. Still it is in progress. Let's wait for some time. And let me go and check that out. Clear this screen. 99. Yes. Now you should see 22. See? 22. Now you can see CIR, right? CIR.
Yeah.
So like that. Their internal
So
system process.
preference of like V Smart 1, like how it will be, which
We
V Smart
haven't
will be
we
preferred
we
first?
we haven't provided any preference here. So by default, it has taken by default, maybe with the low system ID, it has preferred this. But we can do that. We can create a group and we can prefer one VS Smart group then the other. That's the same exact question we have in our CCI training, that it is mentioned in the question in one of the solution. It is mentioned that your for example, branch 2. So branch 2 CH1 will go and form the relationship with data center CH21, and branch 2 CH2 will go and form with that. So for that, what we have to do, that we have to go and do the grouping. So there is one concept called affinity in VSmart that you can go and group the VSmart. Suppose this is VSmart group 1 and this is VSmart group 2. Now group 1 will go and form the control connection only with the selected edge devices, and group 2 will go and form only with this. But this will work as a backup, and this will work as a backup. So we can do that. That option is there and it's very easy to configure. Just one line configuration is there.
But if this affinity is not configured, so
By default, it will take how the load balancing is happening, how the load balancing protocols they are working. Like that, the system will take decision. Suppose if we have only one VS Smart, then
yeah. So I think the configurations which we are in the way we are doing it will prioritize the VS Smart selection on the basis of that. Like if we are putting entry of VS Smart, like having IP222, so it will take first preference to that and second preference to 12.2.12, vice versa.
I agree with that. I think if you go here, 1 second, let me see here. If you go to system-wide configuration, and you have that option. Let me go to system and then type question mark. Let me show you this. So you have that option called, let me see, controller group layer. This see controller. So you can go to controller group. So let me show you this. What is that? Branch to right. So yes to right. So I'll go here, config system and controller group. Is suppose 10. But I can't commit actually. This should be outside. So what I can do here, you can see this configuration. I can go to VSmart and this VSmart to I'll put under group 10, right? And then I'll go to this branch TC1 and here controller group list, I'll give 10. That's it. So now it will go and form the relationship only with the, oops, this one is. So if I go here and go to system and controller 10 and commit. This is not attached. So now it will go and form the relationship only with this as a primary. Just one line command. That's it. One line command. So you can do that. Actually, we are doing this. Suppose if you have good number of edge devices, you don't want to peer all the edge devices to all the VS Smarts. So then you can group the edge devices and peer with group of VS Smart, and then you can group like odd and even VLAN. So group the odd sites, even sites, and map with the odd and even number of VS Smarts that you can do just to optimize the control connections. All right, so I think we're good here.
And
If
one
you have
more thing, how often these CHs sync with VS Smart? Like if suppose VS
I'll
Smart
take
get the
this question.